So in this video, we're going to take a look at how to solve simultaneous equations graphically. Now, what we mean by simultaneous equations is something like the example in front of us here. We have two equations with two unknowns, x and y in this case, and we need to find a value for x and for y, which is going to make both equations work. So for example, 10 and 10, x is 10, y is 10, is going to work for that first equation. We're going to get 20, but it isn't going to work for the second equation. So x is 10, y is 10 is not going to work. So we've got to find out what does work, and we're going to use this method where we rewrite them and plot them as lines. So first thing we're going to do is rewrite these in a way that we can easily draw them. So I'm going to move an x from both sides, and that way this equation is going to become y equals minus x plus 20. So that's an equivalent expression that I have written in this way because this is easier for me to draw on a graph. I can easily see the gradient, I can easily see the y-intercept. The second one's a little more tricky. So what I'm going to do is I'm going to add y to both sides first. This is going to give me x equals y plus 2. Now, after that, I'm going to take 2 from both sides to isolate the y on its own. So I'm going to end up here with x minus 2 equals y. And from there, I can swap that round, and I've got my second equation, y equals x minus 2. Okay, now we're ready to plot these graphs. We've managed to rewrite those equations in some format that's going to allow me to plot it. So first of all, let's draw that blue line, okay? Y equals minus x plus 20. Well, the y-intercept is going to be at 20, and I've got a gradient of minus 1. So every time I go 1 across, I'm going to go 1 down, 1 across, 1 down, okay? So we're going to draw that, and it's going to extend all the way through. And we don't know at this stage how much of this line we're going to need. So I'm just going to draw it all the way through, and hopefully that's going to be enough to help us to find the answer. Right, now we've got y equals x minus 2. Now clearly, look, already I haven't drawn my axes perfectly because this one has a y-intercept here, look, at minus 2. So this may happen to you. Let's just draw that on a little bit, right? And minus 2 is here. So we're going to start from there. And our gradient on this one is a 1. So from here, from minus 2, we're going to go 1 across and 1 up, 1 across, 1 up, okay? So this is going to be our line. And what we're going to be doing is looking for that point, and there it is. That's where they cross. Now, that point where they cross, we can read that off because we can just go down and see that the x coordinate is 11, and if we go across, look, to the left, we're going to see that we have 9. Now, this tells us the solution to our simultaneous equations. We have an x coordinate of 11 and a y coordinate of 9. This is the solution. 11 plus 9 does make 20. And if I do 11, take away 9, I do get 2. So we plot the lines, we find that point of intersection, and that reveals to us the solution to our simultaneous equations. Okay, let's take a look at another example. This time we have got x plus 2y equals 18 and 3x minus y equals 5. So the first thing we've got to do is be very confident moving these equations around and rearranging. In general, we're making y the subject. So in that first equation, I'm going to take x from both sides. I'm going to have 2y, therefore, is equal to minus x plus 18. Now I'm going to divide by 2, and so if I divide by 2, I'll have y equals minus a half x plus 9. So that's going to be my first equation, written in that nice form, y equals mx plus c. The second equation, Well, I want to isolate the y. Because y is negative, I'll move it to the right first. So I'm going to add y to both sides. So that is going to give us 3x is equal to 5 plus y. Now I'm going to take away the 5 from both sides. So I'm going to have 3x minus 5 is equal to y. And now I can flip it round and I can rewrite that as y is equal to 3x minus 5. Now I've got my two equations. I'm ready to draw my graph. Okay, so let's start off with that blue equation. Clearly it crosses the y-axis at 9, so I'm going to mark that point there. And the gradient is negative a half. So I know that my top part of that is like my y. It's going to go back 1 because it's minus 1. Okay, so down 1 and across 2. Down 1 and across 2. Okay, I'm going across 2 because that denominator is 2. This is my steepness of like minus a half. So if I carry on and I draw those, it is going to look something like that, although I'm sorry, that's not the straightest of lines. Okay, now we're going to draw this red line. We're going to be starting down here at minus 5. Our y-intercept is minus 5. We go 1 across, 3 up because of that gradient being 3. And already we can probably see where these lines cross. Okay, let's identify that point. Let's zoom in on it. So it's this point here. This is the point 4, 7. So the solution to this is x is equal to 4, y is equal to 7. Let's check this. Does it work? Well, if I have 4 plus 2 lots of 7, which is 14, yep, it makes 18. If I have 3 lots of 4, well, that's 12, and I take away a 7, yep, I get a 5. This is correct. Okay, now in this last example, this will take me a little while. Let's do a worded one. And this time we'll have to think about how we're going to draw the axes as well. All right, in the previous two examples, the axes were kind of given to us. Let's see if we can figure this out with nothing at all given to us. So, two numbers x and y are such that their sum is 24 and their difference is 6. Okay, if the numbers are x and y, write down a pair of simultaneous equations. Well, if their sum is 24, that is going to mean that when I add them, I get 24. X plus y equals 24. And if their difference is 6, well, that means when I do one take away the other, I'm going to get 6. So it doesn't matter which way around we do this, but let's just say y minus x is equal to 6. And those can be our two simultaneous equations. Now we're going to have to graph these. Now, before we do that, let's just rewrite these in a better format that's going to help us to graph them. So I'll take x from both sides from the top, and I'll end up with y equals minus x plus 24. And then if I add x to both sides on that lower of the two simultaneous equations, I'm going to have y is equal to x plus 6. Okay, now I'm going to draw the graph. Now, before we start drawing, let's just think carefully about where we should draw these axes. Now, clearly, if we're going to draw that y-intercept, I'm going to need to make sure I go as high as 24 and as low as 6 on that y-axis. And also, one's going to be going down from 24 because I have a negative gradient, and this lower one's going to be going up from 6. So in this case, I'm only interested in the positive x and y axis, that first quadrant. So let's start drawing and see what happens. So I'm going to go down, and I'm going to need to draw quite a long way here because I need to make sure I've covered at least 24. And I'm going to go across as well. Okay, we're only in that first quadrant. I've already worked that out. Let's mark some points. Let's mark a little dash every 5. So 24, I've just got enough. Oh, whoops. I've just got enough in there. There's 25 there. 20, 15, 10, 5, 0. Okay, and let's mark the same on that x-axis. 5, 10, 15, 20, 25. Okay, so we've got our x and our y-axis. That should be enough to be able to see this solution. Let's start plotting our graphs. So we'll do that first one in blue again. We're going to mark the point 24. And every time we go one across, we're going down one because that gradient is -1. So it's going to look like this. So we can continue that on without drawing any crosses. I'm confident I know how to draw that. Okay, we'll stop there, but we maybe need to extend that. We'll see what happens. Then we'll draw the other one. Well, this one starts at 6 because that y-intercept is 6. Every time I go one across, I'm going to go one up. So our next point is going to be like this. And once I've drawn a few crosses, I can clearly see the pattern that is happening. And so I have, look, got my intersection point. This is the point where both those equations are going to work. So what's that going to be? Well, I can go across to find the y coordinate of 15. If I go down, I've got that x coordinate of 9. So this is the point 9, 15. So the solution to my equations are x equals 9, y is equal to 15. Their sum is 24. Their difference is 6. This is the correct solution. Okay, I hope that helps you to understand how you can solve simultaneous equations by using graphs.